In this short demo, we are going to talk about the replication slot in streaming replication. Before you implement this replication slots terminology and terms while you are practicing, just to make sure that you should have a 3-node streaming replication setup ready on Ubuntu 22.04. And this is already mentioned in this. So this is 3-node streaming replication setup for PG16 on Ubuntu 22.04. This entire setup, along with the launching the EC2 instances, is just going to take 15 to 20 minutes. It's not going to take more than that. So if you say it is just 14 minutes, we have completed. All the steps are available over here. We'll just go ahead and utilize this. Now we talk about the replication slots, which we see oftenly in a streaming replication. So we are going to explore what is replication slots and what are their usefulness in case of a streaming replication where we have used, what is their advantage, what is their disadvantage, and step-by-step instruction how to use the replication slot that is already mentioned in the previous demo. So replication set, it's a nice feature which has been implemented in PostgreSQL, where in the standby PostgreSQL cluster can request and receive a specific location in the wall of the primary server. So streaming replication, it's all about the wall which is transferred from primary to standby, and it is resolved through a feature which is called a replication slot. These replication slots or these reserved slots ensure that primary PostgreSQL cluster is going to retain the necessary transaction logs, which are written in the form of wall records, and they will be required until the standby servers they have successfully received and applied on them. In a streaming replication, when we talk about the PostgreSQL cluster, it continuously streams the transaction logs from master to multiple standby cluster. In our case, there are one master and two standby clusters. So if you see this over here, this is our master which we have set up. And if you wanted to see how it is going to do it, I'm not going to write it. So I'll show you the command. If you just execute it on the master node, you will be able to see that there are two streaming replications, two streaming clients, which are receiving this. One's IP address is 228 and another is 28. They are connected through the streaming replication. What happens? These replication slots, they play a very important role, and they help in providing a persistent point to catch up the primary server's transaction logs, which are retained in the form of WAL files. Whenever the primary PostgreSQL cluster connects to the or the standby cluster connects to the primary cluster, it is going to request the replication slot, and the primary server then reserves a slot for the standby server. Over this replication slots, the wall records are transferred from primary to the standby cluster. So in short, it is just a way through which the wall logs will be continuously streamed to the standby cluster. In our case, we have two standby clusters. So a replication slot will be reserved, one for slave 1 and another for slave 2. And the wall logs will be continuously streamed to both the clusters. What is the usefulness of the replication slots? One is transaction logs are very much required just to make sure that uh, uh, standby remains in sync with the primary cluster. So you can say it is a reliable catch-up. Replication slots ensure that standby cluster, they are always bringing up the wall logs from the primary through the uh, replication slots. Even if the standby server disconnects temporarily, in that case, it will be preserved over there. The primary cluster is going to retain those wall records until the standby server reconnects and consumes them. So there is a positive fact and negative fact for this. It also helps in preventing data loss. Replication slots, it helps prevent data loss during the failover scenario. If a standby server fails and a new standby server takes its place, the new server can request the same replication slot. This is again needs to be tested and depending upon which high HA you are using. If it is a small database, then you don't have to fall into such pitholes. It is like you can resync the data if it is very, very small PostgreSQL cluster. The third usefulness is decoupling standby server availability. Replication slots, it is going to decouple the availability of a standby server from the primary server. It is something like that the primary server continuously generate wall records regardless of whether the standby server is connected or not. This allows the standby server to temporarily offline without affecting the primary server's operation. This is very nice. What are the disadvantages of replication slots? It is just positive and negative. Disk space usage. So replication slots reserves disk space on the primary server to store the retained wall records. If the standby server is unable to consume the wall records in a timely manner, it can lead to increased disk usage of the primary server. There is a slot limitation also, and you need to just make sure the standby servers and the slots, replication slots, they should exceed to the total number of standby servers. Potential standby server lag. If the standby server falls behind the primary server due to network issues or resource constraint, the replication slot can become a bottleneck. The primary cluster will continue to retain wall until the standby cluster catch-ups. It's going to increased usage of disk and delayed replication. It can be seen both as a positive and negative fact. What we do, we connect to the primary PostgreSQL cluster using PSQL, and then we just create a replication slot. You can use pg-create physical replication slot, and this way you can just mention the name and it is going to create it for you. When we start the replication process on the standby server using pg base backup -h, this is your PostgreSQL cluster, -d, you mention the data directory location, and then you mention the slot name. If you do not mention the slot name in our demo, we just say -c, we have created it. And the standby server will connect to the primary server and it is going to request the replication slot and start streaming the wall records. You can monitor the replication slots using the PostgreSQL inbuilt feature. Let us conclude. Replication slots, they are a powerful feature that enhances the reliability and flexibility of a streaming replication. They're going to provide you a persistent reference point, and replication slots offer numerous advantages, and it can be disadvantage when you have a disk usage and limitation. Let us see some of the commands that you can use. If you wanted to check the replication status on the primary database, you can just use this. This is my primary. These are the two standby database clusters. So let me clear the screen. And using pg underscore stat underscore replication, I can find out the details. What is the PID, user SSID, username, which is going to perform this, replication name, the client address, and all the details will be over here. And what is the status? It is streaming. And other useful information you can find it out is related to how to check the replication status on the standby database cluster. So you can just go to over here and just say pgstat wall receiver. So this is going to show you the timelines during which the last message sent time, received time, latest, all the information you can find it over here. This will help you in finding if there is some kind of lag between the primary and the standby database cluster. We can also use the query to get more detailed information about the replication configuration. And one demo you can try in our case, we do not have the data as of now. We can break the replication and let us see what is the usage. This increases the wall usage. This is 1.1 during the last demo which I have done. So what I'm going to do is let me add one more zero. So let me show you. It is going to utilize your disk space. And before that, let us stop the replication. Just to show, we are going to stop it over here. It is temporarily unavailable. We are pumping in some data on the master, and then we see what is the wall usage over there. Generated very less data. We need to give one more zero. Ah, we need to give some more data, so we can just say hope it doesn't fill up the entire. It should not go down. If it goes down, then it's really bad. I just wanted to see when you, so it is going to increase your wall log files. Ah, still it is very less. 1.2, speed up. 1.3, 1.3, 1.4. Let us see over here. Still 1.1, 1.1, 1.3 over here, 1.1, 1.4 on the master. The idea to say is replication slot, it is, there are two ways of looking at it. One is it is going to preserve the wall files, and other part is if there is some configuration problem, in that case it is going to be a big problem because it is going to overusage your operating system space, and sometimes this will fill up everything so that nothing is going to work. There's no space. I need to remove some data, then only it is going to work. Let's start it as back. Let us start. The idea to say is replication slots are a great feature in PostgreSQL, and you need to just make sure that you efficiently use it. Just few commands just to create drop and other things you can check, and they ensure that your replication remains intact using the streaming replication. We could have taken a bigger system and then it would be easier to showcase you like how it is working. 1.4 GB over here. It's 1.2. The connection is established after this is how your streaming replication slot is going to work. This is really very nice feature and it should be efficiently used.